Everyone may not have done that yet.
An experiment was conducted where 16 10-month-old babies observed two toys, one behaving nicely and the other meanly. The amount of time spent watching each toy was observed. The difference in time spent watching the mean toy versus the kind toy was normally distributed with a mean of 1.14 seconds with a standard deviation of 1.75 seconds. A. State the null and alternative hypothesis to determine if babies spend more time looking at the mean toy.
For the null, we had the mean equals 0. And for the alternative, we had the mean was greater than 0.
And this is the mean of the difference. Why are we setting it up as a difference instead of two separate samples?
Because it's the same babies watching two different.
Right. This is matched pairs data because we have one baby watching two different scenarios and comparing their reaction.
So then we go to stats, test, number 4, and put in all of our information.
Okay, so if you would write down the T and the P, that would be great. So do you guys know when you go stats test number 4? Those of you that are in your seats, we're going to base this one off stats. Oh, hold on. It's not stats test number 4. Which one is it?
I don't know what it is.
0.
Stats test.
That's right.
Which one do we?
I have it on my notes.
Well, just look. We have one sample, right? We're talking about a mean. 2. Number 2. We're just doing the T test based off our stats. So the mean of the null is 0. The X bar is 1.14. Standard deviation 1.75. The number was 16. Testing greater than.
Putting it all
Okay.
in the calculator.
And what did we get for a T?
That's a really good
Did you guys not even do the problem?
No, we didn't.
No, we haven't, but it's wrong because we put in
It's
the
wrong.
stat test.
Oh, well, if you go to stats test 4, it's asking you for two different means. So
That's why we were confused because we put one in as
Because
1.14,
when I
the
put
other
my
one in
stuff
as
in,
0.
it said that it was an error.
Okay. So let's kind of run through this. If you only have one group, and since we are looking at the difference, that's the one group. So we go stats, tests. If you go number 4, you see it's asking for a ton of stuff that we don't have. We were not given two different standard deviations and numbers and means. So we know that one's not right. So we just need the regular t-test. Basing it off our stats, mean of the null was 0, mean of our sample, what did we say, 1.14? Standard deviation, number, testing. So then we have our T and our P. So what's our conclusion? Reject or fail to reject? Reject. Why?
Because P is less than alpha.
Right. Since P is less than alpha, we reject the null hypothesis. And when you're doing these on the calculator, the work that I want you to show is at least your T and your P value. If you would jot those down, that'd be helpful.
My calculator keeps giving me an error. I don't know why.
Yeah.
I don't know what happened. Thank you.
You're welcome. All right, number 2.
Ella, it is a common belief that SUVs are safer than cars. The table shows damage in doll hairs to each after they were involved and they crashed together. Suppose the data is approximately normal with no outlier. State the
On the
null
flat
and
part.
alternative hypothesis. To determine if the repair cost for the car is higher. So the null. And the SUV.
Okay, can I ask a question?
Yeah.
Are these two totally different independent samples or not?
They're not cluster, they're matched pairs.
It's matched pairs. Why?
Because they're involved in accidents.
Because they're in an accident together. I didn't take an SUV from one accident and a car from a different one. I did them together. If it's matched pairs, then the null has to be the mean of the difference. So when it's matched pairs, that's when we did the difference. So null would be the mean of the difference equals 0. That's like saying they are the same. And the alternative would be, we want to see if the car is higher. So remember when we set this up, if we're dealing with the difference, we did 1 minus 2, right? SUV minus car. If the car is higher, what would we get? A negative. So it would be less than 0 for the alternative.
Okay, so since we're testing it at the 0.02 level of significance, we're going to go into stat, edit, and then plug all of those numbers in, and then we're gonna go to stat test number 2, the t-test, and then we're gonna base it off the data.
So remember when we did the difference,
Oh, we put it in L3.
we did one of them in L1. And we did the other one in L2. And then what did we have to do if we're dealing with matched pairs?
Put it in the L3 difference.
Okay. So we went over to L3 and we set that to be L1 minus L2. Is everybody paying attention here? Okay. So then when we went to our stat test number 2, we're basing this one off data. The mean of the null is 0. The list should be L3, that difference. We are testing less than. So then we get our T and our P. So what's our conclusion? Right. Since P is less than alpha, we reject the null hypothesis. So we have enough evidence to conclude that the car repair costs are higher. Does that make sense? Let's go part C on this one. Asked you to make a 98% confidence interval for the mean difference. So I kind of gave you a clue there that we're talking about the difference. So how do we do the confidence interval?
Go into stat, test, and go down to 0. Then you select data, make sure it's in L1, L2, frequencies all 1, make sure it's at 98%.
Hold on. If we're going to do it for, we went to 0 when we had 2 separate samples. But if we're looking at the difference, we just want to build the confidence interval for that difference. So what did we go to instead of the 0? Number 8. We just did the regular t-interval. No, you guys just treat them as independent, and they weren't. So if we went... So hopefully we're seeing the very first question we need to ask ourselves every time is this matched pairs or not? If it's matched pairs, that's when we have to do the difference. Otherwise, we're doing the two separate samples like we did yesterday. Is that okay with everyone? All right. Number 3. Thank you.
Okay, we can cook on this one. I
Better
wanna
chance of us being right.
I wanna write.
We burn.
Heck.
Wait, so hold on. How do we know that we need to read that instead of the other way we did it?
You have to, when you read the problem, you have to ask yourself, is this data paired up in some way?
So it's matched pairs, that's why we did it.
Mm-hmm.
So
Okay.
they just have to like relate.
They have to like be the same number of.
Yeah, so like the two ones we've done were both matched pairs. The first one, the babies, because you had one baby watch two different things. Second one was matched pairs because we had one car accident and we took the two vehicles in the one car accident. So they were paired up.
Okay.
All right, read this one to us.
Find if the mean of the first sample is larger than that of the second. I can use alpha equals 0.05 level of significance. Assume the data is normal. Make sure to state the hypothesis and conclusion.
Did I say anything that would make you believe this is matched pairs? No, two separate samples. In fact, could it even be matched pairs? Why?
Because the ends don't.
Yeah, my ends aren't even the same. If it's matched pairs, they have to be the same amount in both. Okay, so how'd you do it? All right, we're going to base this off stats. Mean of the first, standard deviation, number, mean of the second, standard deviation, number. Okay, but what do we need to write down here?
Null and alternative.
Okay, jot that down for me. Okay, so then we are testing greater than. Pooled, I've told you, we're just leaving as no on everything. Calculate. So the T is 1.2372. Probability 0.1144. So what do we say? Why? Right, since P is greater than alpha, we fail to reject. All right. Any questions there? Okay, next problem.
Let's go. So, I don't know if there's much to write on the board.
You might at least make a list of how you group the information, like Republicans, mean standard deviation number, Democrats, so we know what to put in the calculator. Okay, are you reading the problem to us or telling us what's going on here?
They in a poll, 513 Republicans were asked how many cents of each dollar paid in taxes were wasted. The mean was 54 cents with a standard deviation of 2.9 cents. So that's the mean. Yeah. the same question to 513 Democrats, and the mean was 41 cents and 2.6 cents standard deviation. And then we go into stats test 0 and plug it all in and get. How do you
Here.
erase?
I'm going to go ahead and just pull this up here.
Okay.
So stats, test, we have two different groups. Is there any way that this is matched pairs data? No. So I did not tell you that they were matched up in any way. We have the stats, mean of the first group, 54, standard deviation, 2.9, number, 513, mean of the second,
It's 41.
okay. It's 41, standard deviation of the second, 2.6, number of the second, also 513. Oh, I went to the wrong thing. I went to interval, didn't I? No, that's what we're doing. Never mind. And then we have 0.95. Okay, so we get a confidence interval between these values. So that means we are 95% confident the Republican mean minus the Democrat mean is somewhere in between these values.
So like, it's not matched pairs, but it's like one question asked to two different groups. Would we just like determine that it's not matched pairs because it gives two separate like means and standard deviations?
Yeah, you could. And because we didn't, like, we had the two separate groups, but I didn't take a person in each group and pair them up in any way. So the individuals weren't matched up. Other questions? Okay, last one. I think, isn't it?
Yeah, it is. Okay, researchers wanted to determine whether reaction time in seconds differs between males and females. The results follow a normal distribution and are shown below. Test whether there is a difference in reaction time between males and females at the alpha level of 0.05. Make sure to include the hypotheses and conclusion. So the hypotheses. No, I didn't. Sorry. And there are hypotheses. Alright, and then you went into this, into L1. Oh, I'm sorry. L1, this into L2. Your T.
0.6194.
So we're going into stat, test, which one this time?
It's I think 4.
Yep, because we have two different samples, two sample t-tests.
And T.
0.54.
So what's the conclusion?
Since P is greater than alpha, we fail to reject the hypothesis.
All right.